So in Chapter 7, Section 4, now we're going to work on some properties of special parallelograms. So special parallelograms are, for example, a rectangle, a rhombus, and a square. So let's talk about what those are, right? I know you know what a rectangle is, but by definition, a rectangle is a parallelogram with 4 right angles. So that's the only thing it has to be considered a rectangle, okay? A rhombus is a parallelogram as well, but it has 4 congruent sides. So to be a rhombus, it has to have just 4 congruent sides. Lastly, a square. A square is a parallelogram with 4 right angles and 4 congruent sides. So if you really pay attention and you notice, a square technically is both a rectangle because it has 4 right angles and a rhombus because it has 4 congruent sides. So again, now that we know what these things are, now we can do these corollaries, which again, they're not really theorems, but they kind of follow theorems. They're very obvious things that you know once you understand a definition or a theorem about a rhombus. The first thing says, the rhombus corollary. A quadrilateral is a rhombus if and only if it has 4 congruent sides. So again, we know by definition what it is. Now they're just doing a corollary where it's this if and only if. And what happens is, remember, you can turn any definition into an if and only if statement. So if you see a drawing and you see that it has 4 congruent sides, like that, then you know that it is a rhombus. And the second thing is, if you're told it's a rhombus, then you know that it has 4 congruent sides. So rectangle corollary. A quadrilateral is a rectangle if and only if it has 4 right angles. Okay, so if I see a quadrilateral and it has 4 right angles, I know it's a rectangle. And if I'm told it's a rectangle, I know it has 4 right angles. So I don't need converses and theorems here. This corollary takes the definition, turns it into if and only if, which we know, remember, that an if and only if is like a if P then Q thing, but notice the arrow goes both ways. It could be if P then Q, if Q then P. That's all the way from chapter 2, if you remember. And so the square corollary says a quadrilateral is a square if and only if it is a rhombus and a rectangle. And again, by saying rhombus and rectangle, we're saying it is a rhombus or it has 4 equal sides. That's what we mean by it's a rhombus. And a rectangle, meaning it has 4 equal angles, like a rectangle has. Okay? And so that's where this comes from. So again, if I go to the original up here, notice ABCD is a rhombus if and only if AB is congruent to BC, which is congruent to CD, which is congruent to AD. When I go to the rectangle, ABCD is a rectangle if and only if all 4 angles are right angles. Or all 4 angles are congruent. If they're congruent, they're right. Because 360 divided by 4 is 90. And then the last one, ABCD is a square if and only if all 4 sides are congruent and all 4 angles are congruent right angles. So when you have parallelograms, right, if we do a Venn diagram, you're going to see here where the overlap is. Okay, remember, rhombuses have 4 equal sides. Rectangles have 4 right angles or 4 equal angles. And notice that squares are where the 2 overlap. They happen to have the 4 equal sides and the 4 equal angles. So really the rhombus part, we don't use that much, so it's not weird to think that a rhombus can or cannot be a square, right? But all squares are rhombuses. The weird one is the rectangle. We don't really think of a square as a rectangle, and yet it is. So what theorems can we draw from specific shapes now? So for example, in the rhombus, once we know something is a rhombus, remember again, it's a rhombus if it has 4 equal sides. Then there's a theorem that says a parallelogram is a rhombus if and only if its diagonals are perpendicular. So that's another pretty cool thing. If I take these diagonals here in the middle, if I draw AC and I draw BD, they're going to cross at 90 degrees. The diagonals are going to intersect in perpendicular lines. Okay, so that's a really special feature. So if I see a quadrilateral or a parallelogram where the diagonals cross at 90 degrees, I know that that shape has to be a rhombus. And again, if it's a rhombus, then I know now that all 4 sides are also equal to each other. So it's a pretty good thing to know. Okay. The second one is rhombus opposite angles theorem. And again, parallelogram ABCD is a rhombus if and only if AC bisects angle BCD and angle BAD, and BD bisects ABC and ADC. So what exactly are we saying? What we're saying is if it's a rhombus, these diagonals, not only do those diagonals intersect at 90 degrees, but they bisect the angles they hit. So BD bisects this angle and this angle and this one and this one. And so it bisects the angles as well. We already know, being a parallelogram, we know that the whole angle equals the other whole angle. But now we know that the diagonals split them into equal pieces, which is really good to know. Again, you're going to use it a lot in the future. Now, rectangle theorems. Well, what's rectangle theorem? Well, the rectangle diagonals theorem, notice rectangle and the diagonals, says that a parallelogram is a rectangle if and only if its diagonals are congruent. So what's interesting here is the diagonals, they may or may not cross at 90 degrees, right? Because that's not unique to a rectangle. That's unique to a rhombus. But what you do know is that the diagonals are going to be congruent. So what I know is that the entire DB is going to be congruent to AC. AC is going to be congruent to BD. Again, it's a parallelogram, so I already know the halves are equal to each other, right? I know that, let's make this point M. I know AM and MC are equal. I know DM and BM are going to be equal, but now I know all 4 of them are equal, which is also very interesting. So here we're going to start applying. And again, notice you're going to have to make some flashcards because it's going to be hard to remember all of this stuff. Quadrilateral ABCD is a rhombus. So again, think about what you know if it's a rhombus. You know all 4 sides are congruent. That's just inherent to a rhombus. Okay? You know the diagonals. Think about all the things you know. Diagonals are perpendicular. So you know this angle and this angle and this one have to be 90 degrees. And lastly, you know that the diagonals are angle bisectors. So you know that this angle and this angle have to be equal. This one and this one are equal. So for example, if that one's 62, this one's 62, this one is 62, and this one is 62. And the same goes for these. So all these things come from just knowing that the quadrilateral is a rhombus, okay? So when it says find the measure of ACD, well, ACD is this angle right here, and it's 62, okay? When it says DEC, so DEC, again, is from here to here to here, it's this right angle. That's 90 degrees. EDC, okay, so that one's going to be a little bit trickier. EDC is going to be a little trickier, and ABC is also going to be a little trickier. So again, if I know that this angle is 62 and this one is 62, I know together 62 times 2 is 124. Okay, so I know angle C is 124, and I know this one here is also 124, right? The whole thing is 124. That makes sense. So I know that angle B and D are going to be supplementary to these. So 180 minus 124 is going to be 56 degrees. And 56 divided by 2 is going to be 28. So I know the whole thing is 56, but each piece is going to be 28. So 28, 28, and the whole thing is 56. So now I can answer those last few questions. Angle EDC is this angle right here, and it's 28 degrees. And angle ABC is the whole thing, which is going to be 56 degrees. And so again, I know a lot about sides and angles once I know and understand what a rhombus looks like and what specific characteristics it has based on the theorems. So I keep going here. It says quadrilateral ABCD is a rectangle, and then it wants me to complete the missing information. So when it says 12 here, it's talking about the side. So I'm going to focus on sides first. Okay, so I know that if it's a rectangle, again, what do I know? I know all 4 angles are congruent or equal to 90 degrees, right? I know that the diagonals are congruent as well, okay? So again, I know that this angle here is 90, this one has to be 90, this one's 90, and this one's 90. And then I know typical things of a quadrilateral, that is a rectangle. That means it's a parallelogram. I know this side is parallel to this. This one's parallel to this one. And I know that these are equal to each other as well, right? The opposite ones are equal. Now, I know that my diagonals are congruent, and I also know that they bisect each other. So I know that if this one is 12 here, I know this is 12, and I know this one has to be 12, and this one is 12. So if you ask me for the length of PL, which is from here to here, I know PL is 12. And if you ask me for the length of MO, which is the whole thing, it's going to be 24. So this is units. I don't know if it's inches or feet or whatever. So basically, that's what I know about side lengths. Now we're going to work on angle measures. And the first angle it asks me is about PON. So PON starts here, goes to O, and goes to N. So it's basically the whole angle. Well, I know the whole angle is 90 degrees. Okay? And then the next question asks me about angle PMO. So from P to M over to O, which is this piece. Well, again, I know that this whole angle here is 90 degrees. So if I do 90 minus 29, right, I'm going to get 61 degrees, and that's going to be the measure of PMO, because 61 and 29 is 90. And so that's how we find the angles and the sides. But again, you have to really memorize the theorems, because once you read the word rectangle, you have to know all 4 angles are 90 degrees. Diagonals are congruent to each other. Diagonals bisect each other, right? Diagonal, that's traditional to, or that's unique to a parallelogram. So you know the diagonals bisect each other as well, okay? You also know that the opposite sides are congruent. You know all the things you know about parallelograms, and then you know these two, which are specific to rectangles. And then last one, quadrilateral MORE is a square. So again, what do you know? First of all, I know a square is a parallelogram. And so by knowing it's a parallelogram, I know all the things I learned in previous sections. The opposite sides are congruent, opposite sides are parallel, opposite angles are equal, consecutive interior angles are supplementary, diagonals bisect each other. All that happens. But then when I know it's a square, I know extra things. I know all 4 sides are congruent. that's unique to a square. And I know that all 4 angles are congruent or 90 degrees, right? So let's see what they're asking me here for. They're telling me that ME is 7x minus 3. And they're telling me that MO is 6x. And they want me to find x. Well, remember, in A, I know all 4 sides are congruent. So I know that ME has to equal MO, or be congruent to MO. So 7x minus 3 has to equal 6x. I'll solve for x. I'll subtract 7x from both sides, and I'll get that x is 3. Okay, so x is 3 is what they wanted. So I'm done there. The last thing, the question B says, if MT is 4x, and I'm not sure that this is going to go with the original, so I'm going to just start a new problem. MT, oh, that's not MT, sorry. If MT is 4x and TE is 3x plus 2, find OE. Now, OE, notice, is the whole side, okay? Well, first of all, let me just figure out what x is. So I know that MT is going to be congruent to ET, or TE, okay? And I know that because, again, I know that a square is also a rectangle, and if it's a rectangle, I know that these 4 pieces have to be equal to each other, okay? So I know that 4x is going to equal 3x plus 2, x equals 2. So now I come back over here and I'm like, okay, ET, I keep calling it ET, TE equals 3x plus 2, and if x happens to be 2, then it's going to be 6 plus 2, or 8. So TE is 8, this piece is 8, so together OE must be 16. And it is, okay? So again, once you know your rules, this stuff is easy. The problem is, what do you know? And making sure that you back it with a theorem or a corollary or some definition that you were given to allow you to know that.